Hello again, this is Kenneth Wong, contributing editor for Desktop Engineering magazine. So, in the latest release of Solid Edge with Synchronous Technology, that'll be SC with ST4 for short, the software introduced two new mesh types. One is called beam elements, and that's for analyzing structures built in Solid Edge frame generating environment. Another one is called surface mesh, and that's for analyzing sheet metal objects as a collection of 2D planes. I'm going to take a closer look at both of those. In Solid Edge, you can create frames and structures by drawing a series of crisscrossing lines. They represent the intersection of the beams. Then you pick the standard frame or beam type and let Solid Edge generate the frame along the sketch you drew. Now when you launch into the simulation environment straight from frame making environment, Solid Edge instantly presents you with a mesh type not usually available, and that's called beam element. This is very important. If you create your frame, then leave the frame environment and get back to assembly mode. Then get back into simulation. Sometimes you might not get the beam elements as one of the mesh options available. So remember that. Now once you launch a new simulation study, you'll be prompted to define, or select rather, the geometry you want to analyze. When you pick the frame, you'll find that Solid Edge has simplified the structure to a series of 2D lines. At that stage, you can apply load, pressure, and fixed positions to the lines the same way you do to a solid piece of geometry. When all the simulation conditions have been filled in, you can specify the material, that is, if you haven't done so, and start meshing the model. Then there is hardly anything left to do but to solve the analysis scenario, so you let it run. Here then are your results, captured as an AVI file, to show how the deformation takes place on your beams. The 2D cross-sections, of course, save quite a bit of time for meshing and solving, as the calculations are much simpler. And with much less time to mesh or wait for the results to come back, you can try out several versions of your frame designs till you find out what you think is the strongest option to take on the load you're anticipating. In a similar fashion with sheet metal parts, assuming of course the geometry meets the standard requirements of sheet metal characteristics, Solid Edge will offer you the surface mesh option. Now with this option, you need to first describe how to extract the mid-plane surface, essentially telling the software to create the slices from top side or bottom side at a certain distance. It's important to get that step done before you define the geometry, otherwise you might not be able to define the geometry. Oddly, in the interface, define geometry comes before defining midplane comes. Once you've got your midplanes, you're ready to apply load, pressure, and fixed positions to your design, just like you would do to a solid piece of geometry. And at that point, you're ready to solve the analysis, so you go ahead with that. Here then are your results for the sheet metal analysis, displayed in 2D planes. The ability to turn frames into straight lines for analysis, or to turn solid plates into 2D planes, of course, is a good method to save unnecessary computing times with meshing and solving. This in turn translates to more time left for you to create alternative versions of your design, so you can be confident that you can end up with the best possible idea. We'll take a look at more aspects of solid edge with Synchronous Technology 4 later in subsequent video reports. For now, this is Kenneth Wong for Desktop Engineering Magazine, learning more about beams and planes.